In this video, we're going to look at another example of volumes of revolution using the washer method. The question here is to find the volume of the solid obtained by rotating the unit circle x squared plus y squared less than or equal to 1 about the line x equals 2. Let's first solve for x in terms of y so we can get the outer and inner radius. We have x squared plus y squared is equal to 1. This is a circle of radius 1 with center at the origin. If you solve for x, we get x squared is equal to 1 minus y squared. Take the square root of both sides and we get x is equal to plus or minus root of 1 minus y squared. Now this part, x equals root of 1 minus y squared, is a right half of the unit circle. And this part, x is equal to minus root of 1 minus y squared, is a left half of the unit circle. So let's define the outer radius and the inner radius. The outer radius is a distance from the axis of rotation to the farthest point on the slice that you've drawn. So the outer radius is going to be 2 minus the x value that belongs to the left part of this circle. So it's 2 minus root of 1 minus y squared. And of course, minus minus is plus, so the outer radius is just 2 plus root of 1 minus y squared. It makes sense that we would add it because it has to be more, not less. The inner radius is a distance from the axis of rotation, which is x equals 2, to the closest point on the slice that you've drawn. So it's this distance here. So it's 2 minus the x value that belongs to the right half of this unit circle. So 2 minus the x value for the right half of the unit circle, 2 minus root of 1 minus y squared. It's very important that you understand how we got the outer radius and the inner radius, because after that it's just computation. But it's really easy to make a mistake on that. So take some time to really digest that and to make sure that you understand how we found the outer radius and how we found the inner radius. All right, so now we have our washer here. We have the inner radius defined as 2 minus root of 1 minus y squared. We have the outer radius defined as 2 plus root of 1 minus y squared. And we can now define the washer volume, differential volume, is equal to pi times outer radius squared, that's 2 plus root of 1 minus y squared, all squared, minus the inner radius, that's 2 minus root of 1 minus y squared, all squared, close the bracket, dy. The volume is going to be the integral dv. Add up all these differential volumes, all these washers, and we integrate from what are the limits of integration? It's going to be from minus 1 to 1. And the reason is because that defines the y value of integration from y equals negative 1 to y equals 1. We're adding up these washer slices in the y direction. We're adding them up in the y direction. And so we're adding them up in this direction. That's what the integral is doing. All right. So the volume is going to be, let's write this down. We get pi times integral from negative 1 to 1. Outer radius squared, that's 2 plus root of 1 minus y squared, all squared, minus the inner radius squared, that's 2 minus root of 1 minus y squared, all squared, and let's enclose the brackets here. Integrate with respect to y from y equals negative 1 to y equals 1. So that's the definite integral. We're now going to solve this definite integral. But before solving it, we really need to simplify the integrand as much as possible so that we can do the integration fairly easily. So we're going to just FOIL this out. This is like a plus b squared, which is a squared plus 2ab plus b squared. So volume is equal to pi integral from negative 1 to 1. So 2 squared is 4, and we get 2 times root of 1 minus y squared, that's 4. Root of 1 minus y squared, and let's square this term, we get 1 minus y squared, and minus. Now for this term, let's FOIL it out. 2 squared is 4. The middle terms multiply out and multiply that by 2, so we get minus 4. Root of 1 minus y squared, and square the second term, we get plus 1 minus y squared. Very easy to make mistakes here, so we have to do this very carefully. So let's bracket everything, and let's put another outer bracket here and integrate with respect to y. Let's open up the brackets and simplify. We'll do this really carefully. So we've got 4 plus 4 root 1 minus y squared plus 1 minus y squared. Distribute the minus sign. Minus 1 times 4 is minus 4. Minus 1 times minus 4 is plus 4. Plus 4 root of 1 minus y squared. And minus 1 times 1 minus y squared is minus 1 minus y squared. And let's put all of this in brackets. Integrate with respect to y. So let's simplify. We have 4 minus 4, that cancels out. We've got 1 minus y squared minus 1 minus y squared. This also cancels out. We have 4 root of 1 minus y squared plus 4 root of 1 minus y squared. That doubles up, and we're going to get volume is equal to pi integral from negative 1 to 1, 8 root of 1 minus y squared dy. Now 8 is a constant, so it passes through the integral. We get 8 pi integral from negative 1 to 1 root of 1 minus y squared dy. How do we integrate a function like this? Well, one way to do it is to use trigonometric substitution. Y is equal to sine theta, dy is equal to cos theta, differentiate both sides, and set up a triangle. Sine theta is equal to y over 1, so its hypotenuse is 1, opposite is 1. Opposite is y, hypotenuse is 1. Now we can apply Pythagoras, find the missing side, and we get root of 1 minus y squared. But that's too much work, and it's too hard. It's good practice if you need to practice with the method of trigonometric substitution, but we're going to do something easier. As we're going to use high school geometry to solve for this integral. So I'm going to erase this. All right. So let's look at step 3. So in this step, we're going to compute the integral using high school geometry. Volume is equal to 8 pi integral from negative 1 to 1 root of 1 minus y squared dy. Our goal is to evaluate this integral without doing much integration, without doing much work. So we're going to apply geometry to do this. Notice that x equals root of 1 minus y squared, which is the integrand, is actually the right half of a unit circle of radius 1. So here it is. And we're integrating from negative 1 to 1. The radius is 1. So what is this area going to be? Well, the area of a semicircle is going to be pi times radius squared divided by 2. But the radius is 1, so we get pi over 2. This is the area of a semicircle of radius 1. So the most important thing to notice is that the integrand, root of 1 minus y squared, is a semicircle with radius 1 and is the right half of a unit circle. So the integral from negative 1 to 1, this definite integral, can be represented by the area of this semicircle, which is pi over 2. So entire volume is equal to 8 pi integral negative 1 to 1 root of 1 minus y squared dy. And this integral, we applied circle geometry, and this integral comes out to be pi over 2. So the whole result is 8 pi times pi over 2. And 2 cancels with 8, we get 4 pi squared. This represents the volume that's generated when we revolve this unit circle about the line x equals 2. Notice when we do this revolution, we're going to get a tube. It's also known as a torus. So you're revolving this whole circle, the entire circle, about y equals 2, and you're going to get this tube-like solid. All right, thank you.